Hey guys, this is my new doorbell. So it's broadcasting in vivid SD, NTSC, 720 by 480 scan lines of resolution. As you can see here, quality is very good. So it basically generates analog video, and I drive that over two-wire twisted pair all the way to my DVR, which is encoding it currently, I believe, 30 frames per second, then records to a hard drive. Then also it's a doorbell. So I have hooked up the doorbell to a relay which drives a 24 volt AC sinusoid which drives a doorbell. But this one's a digital doorbell, so it has a rectified wave so that you can do all the cool stuff. So let's see if that works. I'm ringing the doorbell. There it is. So doorbell works, everything works. So I'll show you how I did it.
Hey guys, this will be a video on the installation of a security camera wired doorbell installation on your house. So why am I doing this video, and what's the complication? Well, so apparently a wired security doorbell doesn't exist. I don't know why, because the wireless version, like for example the Ring product, where you mount it on your house and you wirelessly can record video and on your smartphone, it's a great product. But because I already have an existing DVR, I want to find a wired version. Because the Ring product, it saves the video on an SD media, which is okay, but you know, that's not very much useful, and not much useful to you. So because I have a DVR system, a wired DVR system, I want the same thing, except I just want it from a wired camera. So that's the whole purpose of this. So I did some searching, and apparently that doesn't exist. So a wired security camera on a doorbell doesn't exist. Boom, done. So that's ridiculous. So I don't know why, but a little bit of searching on eBay, and the only thing I could find is this Chinese product. It's a Chinese security system. So you have this doorbell on the outside, and there's a wired connection to a digital color panel that goes into your living room. So the idea is that this thing communicates with that, and you can go back and forth. Now, I don't want that intercom system. I'm not interested in that, but I am interested in this. And I figured that if it had a wired system, then I should be able to reuse it for my own purposes. So that was the first complication to this project. So I went ahead and ordered it. Came in last week. I played with it a little bit, and it looks really promising. So I think this is a good solution, and this is going to work. So the next part of the project is to interface this to a doorbell. So I figured, okay, well, that shouldn't be too hard, right? Well, turns out actually it is. So the doorbell, because this is a digital product and it's all got data, there's no actual push button here, right? This is just data. So I can't interface with a traditional doorbell very easily, right? So, but I did a little bit more research, and apparently there's digital versions. So this is a digital doorbell, which sounds good, but the problem is that this one still works with an AC transformer. So all doorbells are AC. The digital version is actually still taking an AC signal, but it's rectifying it internally and using it digitally. Also, you know, this one's got batteries, which makes it a wireless and wired system. But the problem with that is, yes, you can put in batteries, but this is only for using it with a wireless doorbell, which is not what I'm trying to use, right? I wanted to use a digital doorbell interface with a digital, push button with a digital doorbell, and that you can't do that either. So I did a little searching, a little bit debugging. I'll talk about this in a bit. I did find a solution, so I just tested it. It looks like it's good, so I'm going to go with that. So that's the second part of the system. The third part of this project is another complication, which is I ran Cat5e Ethernet cable from my basement all the way to the doorbell, which is in the front foyer, and out to the doorbell button, which is outside. So my solution all has to work writing into, putting the signals inside a Cat5 Ethernet connection. Twisted pair, 8 cable, 4 pair. So the complication with that is that I don't want to run an AC signal inside this Cat5e while still driving video, because I'm fairly certain, even though it's twisted pair, that the noise coming from this transformer is going to induce into this video signal. So I have to still come up with a digital solution to this. So in my brain I came up with a solution. I think it will work. I haven't tried it yet, but we're going to go through this. I'm going to put this together. I'll document everything, and let's see if this works. Okay, so here we are in the front foyer. The wiring you can see here is the Ethernet cable that I routed from the basement, which goes into the top here. So I'll be mounting the doorbell here, and that wiring then I also routed through the brick and exiting here. So this is the mount. I already went ahead and installed the bracket and the wiring. So we'll just plug in the doorbell here. So that's the plan. Okay, so this is the output of the video. So the good news is that right out of the box, if you put power, ground, then you get streaming video. So it doesn't depend on a push button or anything like that. It's constantly streaming video, which is good. That's what you want. So that's good. So the only issue getting this thing set up is that it comes shipped running PAL. So it's for European and Chinese standards. So if you take this thing apart, look at the back of the circuit board closely where the plug-in daughter card camera module is. On the back, you'll see a P and an N. So I took a guess, and I was right, that the P is for PAL, which the resistor jumper was on. So you just desolder that, put it on the N, and the N is for NTSC. So as soon as I did that, plugged it back in, then blammo, looks like the video is good. So I don't know what the resolution is, because this equipment doesn't have video, but most likely it's just SD NTSC. Nothing complicated. It's not an HD camera. But that's fine. It takes looks fairly decent pictures. Looks okay. So according to the manual, this thing's got a range of 15. So a little manual they gave you, 15 volts DC. So which is good, because that'll kind of work into our doorbell circuit later. So that's all good. So let's take a closer look now at the third wire. So that's the yellow wire, which is emitting video. Now we'll take a look at the green wire. All right, so the green wire is where things get interesting. So as you can see on your doorbell, you actually have a speaker here. So you got a speaker, got a little microphone, you got a push button, and you got some infrared lights. And the only wire that's left is this green wire, right? So how do you get all that functionality on one wire? Well, it turns out that this thing constantly streams audio too. So as you can see on the waves here, like hello, 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 this thing is streaming audio, right? So how do you get everything else to work? Well, this is where it gets interesting. Look what happens when you press the button, right? So you're talking, and then all of a sudden you press the button and pow. So now it's ground, right? And when you normally talk, it's a sinusoidal signal. So this has actually got negative components too, right? So this thing is actually, it's an analog bus. It fluctuates. This is the 0 mark, so it fluctuates to below ground, right, to achieve your sinusoid. And when you press a button, it goes to ground, right? So I don't care about audio. I just want to get the button working. But so the problem is, you got an audio signal oscillating around 0, and you got a button that works at 0, right? So how do you differentiate a button press from audio, right? So that's the last hurdle, right? If I can just get this one isolated, then I'm good to go. But I can't do that, right? So I figured, okay, well, why don't we put a pull-up resistor on there to see what happens, right? So just putting a 10K pull-up on our signal, look what happens. Pow! So now we've got a pull-up, a 10K pull-up on VDD. So now our sinusoid is oscillating around VDD, our pull-up voltage. And so what happens to the push button? Pow! Good job. So that's how it works. Now, what's interesting, I don't know if you can hear this, but I don't know if you can see that. I'm tapping this. When I'm tapping this, audio comes out. Hello, 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 hello. I don't know if you can't hear that, but audio comes out. So what these guys have done, this is so interesting, that they're using the green wire as an analog data bus, right? So when you ground it, that's the button that will call to your intercom, your flat panel inside. Then, if you bias it, I'm thinking if you bias it just to a certain level, right, then that range is microphone in, right? And anything above that, which is I'm biasing it too much, right? Then that actually becomes audio out. So you have call, audio in, and audio out. That's your range on your analog bus. Amazing, brilliant. So all I have to do is get a 0 voltage detector so that when you go like this, that's call, and everything else I don't care about, because I really don't care about audio, and I really don't care what the speaker is. So now there's my circuit. It's the 0 volt detector. Okay, so I'm just going to quickly touch on how doorbells work, because this is important in the project. So there's plenty of good videos, much better than mine, on YouTube. So you're welcome to browse those. But I'm going to just quickly summarize that a traditional doorbell basically uses an AC signal to power an inductor, and then there's a gong inside. So normally, as you can see here, how it's hooked up, essentially we have AC voltage completing a circuit. So when the button is pressed, AC travels around, and essentially this gong goes up, and then when you let go of it, it goes down. So that's how you get your ding dong noise, and that is only it only works when you press the button. So you only get sound when you press a button. It doesn't need power any other way, because you can see there's nothing to it. So that's a traditional doorbell. A digital doorbell is a little different, because it needs power all the time, because it plays a chime or some sort of a song while you use it, and then you basically just need to activate that. So although it has nothing, it is not really required to have these old legacy sinusoids anymore, because a house wiring already has this. The technology is old, so the digital doorbell basically just works around it. So whomever came up with a solution, it's pretty ingenious. What you do is you put a diode in between your push button, and what you end up doing is rectifying the sinusoid. So normally this digital doorbell would be getting this rectified half sinusoid, and that's what gives it its power. Essentially internally it just rectifies it, put a capacitor on it, and basically you have a little DC power source, and then when you press the button you essentially short that diode and you give it an AC signal again. So internally it basically detects a negative voltage, and that's how it knows that you've pressed the button. So internally it doesn't need a sinusoid, but that's what it uses to determine what the state is. So press the button, a full sinusoid is enabled, and then we let go of the button, it goes back to this. So this starts the cycle, and then the song plays from here on. And so my solution essentially is to give it what it wants when the button is pressed, but when it's in normal steady state operation, instead of giving it a rectified sinusoid, I give it a DC pulse, DC value, and I tested this on this doorbell, and it works fine. So essentially you can drive a DC signal in the Ethernet cable, and that way you don't add noise to the video signal. I didn't try it by actually trying to rectify it, but anyways, another interesting solution would be to give it a positive DC signal and then swap the leads here. I haven't tried that, but that might be a way where you can get rid of this sinusoid altogether and just maybe just work with one DC power supply, and then a single pole double throw relay could swap those over. Or sorry, double throw, double pole double throw relay will do that. Anyways, this is how I did it, and it works. Okay, so here's our completed circuit diagram. It looks a little complicated, but I'll break it down. It's not too bad. So the heart of the circuit are these two automotive relays, right? So 30 is the output, that's your pole. So normally the 30 is engaged to the 87A. So we connect plus 12 volts to 87A, it goes through 30, goes all the way into our Ethernet cable, then snakes up to the house, goes up to the foyer, and dumps out at the doorbell. So then we connect that to one side of the connection, so we set it to the front push button lug. Then on the second relay we've connected ground to 87, which goes out to 30, which goes all the way in to this twisted pair, again out, and then goes to this. So we have a rectified 12 volt source going to this guy here, and this guy's constantly getting power. Right, so these relays, these are the these are the inductors for the relays. So these are not being engaged, and the default is to have this contactor. Then when they are engaged, then you flip over, and this transformer is then connected to the 87, and the transformer will then flow through there, and then be connected to this guy here. So that would be the triggering of the doorbell. So let's take a look at the rest of the circuit, which is this little guy here. So this is where all the magic happens. The green is connected to our doorbell. So this is our doorbell over here. We've connected it to the green wire, also positive, ground, and video. So video and black are on the orange twisted pair, and the green and the red are on the other twisted pair. And that will all go through the shield all the way up, and then dump out in the front of the house where we've connected it here. Anyways, so green wire then is connected to our transistor circuit here, right? We have a pull-up, 10K pull-up to plus 12 volts, right? That gives us our bias on the up direction, right? So that means that the gate of this NPN MOSFET is always being driven high, right? In other words, that this MOSFET is always on, right? So this is our audio diagram, right? So the audio is always hovering at VDD or 15 or whatever, right? So this is always on, which means that this is connected to ground, and then D is connected to ground. I've put some LEDs in here so you can check. You don't need them, but let's just keep them there. So which means that we have 12 volts going through 10K, going through this LED, and then being driven to ground. So this is on, this is ground. This drives the second transistor. The second transistor is now in the off position, right? Because this is off. This transistor is connected to the other side of our coils in the relays, right? So one side of the coil is connected to 12 volts. The other side of the coil is connected to this MOSFET, which is basically going to allow this to be connected to ground, complete the circuit. But in the beginning, this is off, right? So this is off, this is off, everyone's happy, this guy's getting plus 16 volts. Then when we hit the push button, this guy then shoots down below 0.7 volts, then it will activate below the threshold and will shut this transistor off. When this is off, then the drain then suddenly shoots up to 12 volts through this resistor, and then this activates. This activates, this closes the switch, and this relay then clicks. And then we have now your AC voltage going to the doorbell. And so let's get your ding dong that way. When you let go of the push button, this guy goes back up to 16. This can continue to play the chime while this guy here is back up. This is now connected to ground. This is grounded, so this one shuts off and your relay opens again. Okay, so here we have our circuit. Hello, hello. So we got the audio signal, which is now on the green wire. So as the picture indicated, so we got the pull up, so pull this guy up. We're driving this with our plug-in supply. So this is a supply that we're going to be using. So I want to test it under load to make sure everything's okay. Video's going good. Everything is fine. So let's begin. Well, not much to do. Just press a button. So as you can see, we got the green LED on. I used a multi-leg LED, multicolor LED to make things simple. So basically, that's it. So as you can see here, once we press the button, this guy shoots to 0. It activates the relay. This LED goes red, and that's it. So we're good. Simple as that. Works perfect. Simple. All right, good. So let's put all this together into a circuit board. We'll solder this in. I'll get a little panel so we can mount everything on the panel. We'll hook up the transistor or the transformer, and I guess there's nothing else to do but install it. So. Okay, so we got all the components together. This is everything soldered onto that little mini circuit board. I got power coming in. I'm just waiting on a terminal block that I've mailed in for to put that on this side. Relays screwed into the board. This is our board, the one that we're going to mount on the wall. Transformer here. That's it. So the output goes to our doorbell, and this is our doorbell push button. So light is green, power's good. That's good. All right, let's hook everything up to the house and give it a shot.